All right, today we're diving into a really powerful idea about how to completely re-engineer education. We're talking about shifting from just memorizing handbooks to actually embracing the real thrill of discovery. So let's just kick things off with the big question, the one that's at the heart of this whole thing. We live in a world that is crying out for more innovators, more scientists, more problem solvers. So why are we losing them? Why are fewer and fewer students choosing to go down that path? And look, this isn't just a small dip in the numbers. The source material we're looking at frames this as a genuine crisis, a crisis of curiosity. And that's a problem we absolutely cannot afford to ignore. This slide just lays it all out there. Think of it like a shrinking pipeline. At the very beginning, fewer students are even choosing to major in science. Then, as you move along, that pipeline gets even narrower, with a huge drop-off in master's and Ph.D. enrollment. And here's the real kicker, that last point. Even at top universities, actual student research is often just optional. It's like we're turning off the tap right at the end. And this isn't happening in just one place. It's a trend we're seeing all over the world. So how did we get here? Well, you gotta look back at history. Our university system was designed for the needs of the 20th century. It was all about building an industrial workforce, people who could follow procedures and support mass production. But today, the 21st century is a completely different ballgame. We don't need procedure followers. We need researchers and innovators who can tackle incredibly complex problems and come up with custom solutions. The world changed, but our educational playbook, it kinda didn't. And this, right here, this is the central paradox. And it's kind of wild when you think about it. We require our university professors to be active researchers, to be constantly pushing the boundaries of what we know. But the students, the very people we hope will become those next generation researchers, we've set up a system where they often don't have to do any research at all. It's a huge disconnect. Okay, so if the system is outdated, what's the specific disease? What's the root cause? Well, the source material has a name for it. They call it the Handbook Problem. Let's dig into what that really means. This quote just hits the nail on the head. We have students spending all their time studying these handbooks, these collections of facts and results, but we're completely skipping over the most important part, the messy, brilliant, human process of how we got those results in the first place. We teach the final, polished answer, but we leave out the story of the failed experiments, the wrong turns, and that incredible aha moment. We're teaching the destination, not the journey. I love this analogy because it's just perfect. Right now, we're basically handing students a cookbook and telling them to memorize recipes, but we're not teaching them how to be a chef. We're not teaching them the science of flavor, how to improvise, how to invent something new. We're training people who can follow instructions, not people who can create. Okay, enough about the problem. What's the solution? Well, it all starts with a fundamental shift in philosophy, getting back to the way we're all naturally built to learn. This core idea is called total science, and it's based on a really simple but profound belief. Every single one of us is born a researcher. I mean, just watch a little kid explore the world. They're constantly asking questions, running experiments, trying to figure things out. The goal of education then shouldn't be to stamp that out and replace it with memorization. It should be to protect that curiosity, to nurture it, and to give it sophisticated tools to work with. That philosophy sounds great, right? But what does it actually look like in a real classroom? The source proposes a really concrete model, and it starts with a subject that, let's be honest, can be pretty intimidating for a lot of people: chemistry. They call this model Polytechnic Chemistry. Poly for many, technic for skill. It's about bringing many skills together. So instead of a student taking organic chemistry one semester and inorganic the next, they start with a real-world process. Let's say making ammonia. They then become detectives, tracing its entire history, all the failures, the breakthroughs. After that, they jump to today and see how that same process is being researched right now. And to do all that, they have to use organic, inorganic, and physical chemistry, not as separate classes, but as a single connected toolkit to solve one big, fascinating puzzle. And here's the best part. This isn't just an idea on a whiteboard. Let's look at a program that's actually putting this blueprint into action right now. And it's centered around one of the biggest challenges on the planet: clean water. So this is the Water Treatment in the Middle program, or WTIM for short. It's a master's degree where students don't just read about water treatment, they are doing it. They're in the lab, getting their hands dirty, synthesizing and testing the materials themselves. They're developing the technologies to produce them, and, crucially, they study the whole history, learning to think like the innovators who came before them. It's all about the methods, not just the facts. So what's the end result of all this? Well, you don't just create academics, you create graduates who are ready for real-world, high-demand jobs from day one. They can become researchers inventing new water technologies, managers who deeply understand the science of water purity, or versatile engineers ready for all kinds of industries. They've learned how to actually solve problems, not just memorize answers for a test. Now, this is so much bigger than just one program or one university. This model really gives us a vision for what the university of tomorrow could and, maybe should look like. The ultimate goal is to scale this whole thing up. Imagine an open international platform where educators and researchers from all over the globe can collaborate. They could create and share these research-based courses. A professor in Brazil could build on a curriculum developed in Japan, all of it centered around solving real-world problems. And the vision gets even cooler. It also includes a whole new kind of scientific journal. Imagine researchers writing articles that don't just speak to other experts, but that explain their latest cutting-edge discoveries directly to students. That would completely bridge the gap between the lab and the classroom, making education dynamic and relevant in real time. So, we're left with this one last, really critical question. When we look at how we teach, especially science, we have to ask ourselves honestly, are we preparing students for the complex, unknown challenges of the future? Or are we just teaching them the answers to problems from the past? The choice we make here is going to define the next generation of innovators.